Welcome back to All This Math. This is Professor Parker, and for this next lesson, we're going to talk about geometry and some of the properties of geometry, some of the relationships between angles within geometry, and also some of the vocabulary within geometry, because that's very important. A lot of times, if you can understand the vocabulary that's involved in geometry, then you can do well in geometry, and you'll be able to answer certain questions in geometry. Now, in case you're wondering why I got this whole stack of books under my arm like this, it's because I'm wearing my W.E.B. Du Bois Educate to Elevate t-shirt. And this is actually like a younger Du Bois. He was kind of a youngin', probably maybe in his 30s or something. Even though he was already bald. But yes, in tribute to W.E.B. Du Bois, who was a civil rights activist, a human rights activist, a historian, a sociologist, I would say even a mathematician from all the mathematics he had to do. And incidentally, he also was offered a position at Tuskegee University to come down there to Alabama and teach mathematics. But the only reason he turned it down was because he had already made a commitment to Wilberforce University to go up there and teach. So that's why he didn't end up teaching math at Tuskegee, which is interesting. But what I wanted to do is I wanted to introduce you to W.E.B. Du Bois if you're not familiar with him, or if you heard his name before, like in an African American history class or something, or just in some history class, maybe, but you don't know a whole lot about him. I got a couple of books here that I wanted to put you on to, so you can get to know about him. And these ain't even all the books that he wrote. Like, he wrote a lot more than this. This is just a fraction of the books by him that are in my library. I own a lot of the books that the brother wrote. But this is just a fraction of them, so I'm gonna point them out. So this is called An ABC of Color. An ABC of Color is a book that I got introduced to when I was doing some work with Philadelphia Freedom Schools, probably back in like 09 or 2010, something like that. This is kind of like when I first read this, it was kind of like a Best of Du Bois mixtape. That's how I felt, you know what I'm saying, when I got introduced to this, An ABC of Color. I would check this out. Also, then you got another book that we delved into in Philadelphia Freedom Schools, The Education of Black People. This is a compilation of some of his speeches and some of his lectures and some of his other writings about the title, The Education of Black People. You know what I mean? Throw these down here. This right here, this got some heavy essays in it. You want to check this out. This is Darkwater, right? He got an essay in here called The Souls of White Folk, which is heavy, right? He's talking about a lot of things. He's also got a couple other key essays whose names I can't remember right now, but check out Darkwater. And then we got, and this is where, like, The Souls of Black Folk is probably his most famous book. It's probably his most popular book, most well-known book. Came out in 1903. You know what I mean? The Souls of Black Folk, that's, I like that essay I mentioned, The Souls of White Folk, which is in Darkwater. It's kind of like a play on words, a play on his own work. So he just flipped it and, wrote an essay called The Souls of White Folk, about white people. You know what I'm saying? Then we got The Philadelphia Negro. He wrote this. Well, really, this is like a research text. It's like a sociological study. You can see how thick it is, right? So it's called The Philadelphia Negro. He did a study of Black people in South Philly, near what's currently known as, near what's now South Street, that area, because at that time in the late 19th century, around 1898, before 1898, when this book was published, that area was where the largest concentration of Black people in Philadelphia was. So that kind of was like, I guess some might say the North Philly of Philly, but back in 1896, 1897 and all that. So the Philadelphia Negro, you got that right there. Then we got a couple more. The Black Reconstruction in America, a book he wrote, chronicling and talking about the history of the United States, and especially during the Reconstruction era, which I believe was from 1866 until 1876 with the Tilden Hayes Compromise, I want to say, around that time. So this is, again, it's a thick joint, with a lot of information in it that you can check out. And then, last but not least, The World and Africa. The World and Africa. It's a world history text where he's talking about Africa and the importance of the continent of Africa in terms of a lot of imperialism and colonialism that was taking place in the 18th and 19th centuries, And really, and also one of the things that one of the major takeaways I took from this text is learning about how Africa was really central to the fact that there was a World War I and the fact that there was a World War II. Whereas I remember being in middle school in 7th grade and learning about World War I and thinking that, well, World War I just started because Archduke Ferdinand got assassinated, a couple, white people, practicing white on white gang violence, just shooting at each other, killing each other and whatnot. But the reality was they was beefing over Africa. And that's one of the things that Du Bois writes about, thoroughly in this book. So I just wanted to point out a couple of his books, in case you hadn't heard of him ever, or if you have heard of him, but you never really, really did your research on him, go check it out. All right, go check out some of that brother's work. Now let's get into the geometry. All right, let's get into the geometry. And geometry is very important, not just because, you might be in 10th grade and you need the credit for geometry or whatever, but what geometry does is it helps to train you how to think. It trains you how to think logically, how to think critically, how to, make sure everything balances, everything adds up and everything really makes sense. That's what geometry can do for you. So if you can do geometry and you can take information and construct and formulate arguments and they're valid and you can make valid arguments, then you can also recognize when some arguments are not that valid, right? So let's take a look at this problem. So I kind of should have wrote it a little differently, but what we're trying to do is, well, this is the main question right here. Which information could be used to determine this? And when I say this, I'm talking about this statement right here. This statement right here, that ray LH is the bisector of angle GLI. And these are 4 statements, right, that we're given, A, B, C, and D. These are 4 separate statements that we're given. And we have to look at these and then tell, well, and basically deduce for ourselves, like, if I know this, does that mean that I can arrive at this conclusion, right? Or if I know this, does that mean I can arrive at this conclusion? Or this, can I arrive at this conclusion? Or this, can I arrive at this conclusion? So let me get into it a little bit, but let me first let's look at the picture that we see, right? So I see this line right here. It's a horizontal line. It's got points K, L, and M on it. Then I see a ray. So rays start at a point and going indefinitely, right? I see a ray LI, right? Right here, I see ray LH right here. I see ray LG right here. I see ray LF right here. And, you can look at this as ray LK, right? Or ray LM, or you could just look at it as line KM or MK or ML or LM. It's a lot of different ways you can name a line, But, and then let's look down here. We see this symbol right here above LH. This is the symbol for a ray. So whenever you see this, we're dealing with a ray. If you see arrowheads on both sides, that's a line. But this is a ray, meaning it starts at a point and goes on forever in one direction. If it goes on forever in 2 directions, that means it's a line. So you got lines, you got rays, you got line segments, you got points, you got planes. That's something you're going to see like in chapter 1, section 1 in any decent, geometry textbook, right? Just know what the symbols mean though, right? Because this is like its own language and you got to know what the symbols mean. All right. So we got ray LH is the bisector. Now, let me stop right there. What's a bisector? A bisector is going to be some type of segment or line or ray that's going to cut an angle in half. It's going to cut it into 2 equal sized angles. It's the same way you would slice a sandwich in half and make 2 equal sized pieces, right? So that's what a bisector does, right? So they're saying that the ray LH, which is LH, this right here, this ray right here, right, is the bisector, meaning it cuts angle, it's the angle symbol, GLI. So where's GLI? How do you find GLI? Where's that angle? Point G, point L, point I. Point G, point L, point I. So basically what that means is that we saying that this angle right here, that's in between ray LG and ray LI, right? We're saying that this is a bisector, right? Which is going to mean that actually what I should do is do this. Let me do it like this. So that means that this angle and this angle are equal to each other. If this is a bisector, that means that this angle and this angle are equal to each other. That's part of the definition of a bisector, because that's what a bisector does. It creates 2 equal angles. All right. So now our job is to look at these four statements, right? They look like equations, right? But they're statements. And in a sense, they actually are equations, right? and see, can I look at this and read this, and then will that basically prove that the ray LH is the bisector of angle GLI? So let's read it. This is an angle. This is angle GLH. Where is angle GLH at? That's this angle. G to L to H. That's this angle right here, right? So that's all this in here, right? It's congruent. See the equal sign with the squiggly line on top? That means congruent, or has the same measurement as, right? Angle ILM. Here's I to L to M. All right. Now, from that information and knowing that, that's the question. Can I arrive at the conclusion that ray LH is the bisector of GLI? Can I? I can't, because this angle is all the way over here and this angle is all the way over here. These two angles don't really got nothing to do with each other, right? Remember, a bisector cuts an angle into two equal size angles. It would be this angle and this angle. This bisector don't got nothing to do with this angle over here. So we can't use this. This is not relevant. All right, that's not relevant. All right, and that's how you gotta think about geometry questions. You gotta like really just think about it in terms of like, is this a true statement or is somebody trying to lie to me? Like, is this real or is this cap? That's how you gotta think about it. When you're looking at geometry, you gotta think of it in that mindset. Just like if you was on the street somewhere, or you was out somewhere, or you like, you know somebody, you in class, and you got that person in your class that always be lying, always be frauding all the time. Like, and you be sitting there just like listening to them talk, and you're like, okay, all right, for real, that's what happened. And then you did that. Okay, that's how you gotta like approach geometry. You gotta approach geometry like that. Like ask yourself, does this really mean that this is gonna happen? Really? That's how you gotta look at it. And if you start to look at it like that, then I guarantee you, geometry is gonna start to get a whole lot easier, right? It's gonna start to get a whole lot easier when you start to look at it through that lens and in that type of mindset. All right, let's look at choice B. So choice B, we got M. Now, letter M in geometry stands for the measurement of. That means the measurement of, right? The measurement of an angle, usually is what the letter M stands for, right? Because remember, you gotta know the language, right? So we got the letter M, the measurement of the angle KLM. Now, where's KLM, right? Now, let me erase this because we don't need this no more because we already dealt with that. So KLM. KLM is actually this straight angle or this straight line or straight angle. Now, all straight angles measure 180 degrees. All straight angles measure 180 degrees, right? So we got KLM. So that's this right here. So the measurement of KLM, which is going to be 180. I'm going to just write 180 right there, is equal to 5. Now, the 5 next to the M, that means 5 times M, or 5 times the measurement of. 5 times the measurement of, right? So 5M, or 5 times the measurement of the angle ILM. Now, where's ILM at? It goes from point I to L to M. Point I to L to M, right? So that means that if this is 180 and this is equal to 5 times the measurement of this, that means the measurement of this must be 30, right? Because if you divide 180 by 5, because imagine this was an equation, right? So 180 is equal to 5 times the measurement of this angle. If you divide by 5 on the right side and divide by 5 on the left side, you would get 30. So that means this angle is 30 degrees. Now, does that have anything to do with this being the bisector of these two angles? Does this being 30 degrees have anything to do with that? I don't think so. I don't think it does. In fact, this is the second time I'm gonna just keep it 100 with you. This is the second time I'm recording this video. I recorded it earlier and I thought that it did. I thought that if this was 30, then that meant that automatically these other 4 angles have to each also be 30. That's what I was thinking at first. But I thought I was looking at it a little sideways, like, I don't know though, right? But yeah, that was incorrect. Just because this angle is 30, that doesn't mean that this has to also be 30 and these all have to be 30. As long as all 5 of these angles add up to 180, then yeah, okay, this is 180, but that doesn't mean that they each got to be 30. Like, a couple of these could be 40, and then a couple of the other ones could be, less than 40, right? They don't have to all be, because here's the thing. If these were all 30, then that means that this one and this one would be 30. And if this one and this one are 30, then that means that is a way that you can prove that this LH is a bisector, because the two angles are equal. These two right here. Because all we're trying to do is figure out basically which one of these statements is proof that this angle and this angle are congruent to each other. Because once we prove that, then it means this has to be a bisector based on the definition of what an angle bisector is. An angle bisector, again, it cuts an angle into two equal angles. That's what an angle bisector does. All right, just make sure you know that. That's what it do. All right, now, so B is no good. B does not prove this. B does not prove this. It proves that this angle is 30, but that don't got nothing to do with these other four angles. All right, so A is out, B is out. Let's look at choice C. The measure of angle GLI, which is G to L to I, right? This whole angle, these two angles put together, right, is equal to 2 times. 2m means 2 times. 5m means 5 times the measure. 2m means 2 times the measure of angle GLH. G to L to H. All right, so look, if this whole angle, both of these together, is equal to 2 times the measure of this, then that means that this must be equal to this, right? Because what if this was, now let me erase this 30 right here. Let me erase that, right? Now, what if this was 40, right? If this was 40, and then I do 2 times 40, and I say, okay, well, this whole thing is 80, doesn't that mean that this has to be 40 also? This would have to be 40 also. If I double something, that means I'm taking one amount and I'm adding it to itself, or I'm multiplying it by 2. So just like if you double your money, if you had $100, now you got $200. You had 100 and 100. So if you double your money and you had $300, now you got 600 because you had 300 and 300. So basically, if the measurement of this whole angle is equal to 2 times whatever the measure of this angle is, then that means that this and this have to be the same. So because of that, that fits into the definition of an angle bisector. So that means that this statement right here does in fact prove that great LH is the bisector of angle GLI, right? This statement right here. So if we know this information, then we take this information and we say, okay, yeah, this right here, this is true. That's good money. That's good money. That's true. And we can prove it, right? So, and that's another thing that geometry does. Like it helps us to develop sound arguments and sound positions. So it's like we can always be like facts over feelings, because somebody can say, well, I feel like, you know, LH is a bisector of GLI just because it looked like that. No, that's not what we do in geometry. In geometry, we deal with facts, right? We deal with facts and we deal with reality. So you got to understand the information that you're given in order to be able to then say, all right, yeah, this is true, right? So if this is true, then that makes this true. It ain't about how you feel. It ain't about your feelings. It ain't about none of that, right? You got to just, like in geometry and in mathematics, it's concrete, right? It's no room for like, you know, emotion and feelings and all of that. Emotion and feelings have their place, but not with this, right? So choice C is good, but that doesn't mean that D might not also be an answer. Let's look at choice D. Choice D says the measure of angle GLI. Where we at? Okay, from point G to point L to point I, this angle right here that we was just talking about, right, is equal to 1/2 of the measure of GLH, which is this angle, plus, see my plus sign? 1/2 of the measure of HLI, which is over here. So let me erase this and erase this, and I'm even going to erase this because I want to show what this looks like, right? So 1/2 of the measure of GLH. Where's GLH? GLH is right here. So let's imagine I'm doing an angle that's 1/2, right? And I just, you know, squiggle that. So this right here that I just shaded in, right, is 1/2 of GLH, right? And then I'm going to do 1/2 of HLI. Shade that in. Now, I could have shaded the other side. It don't make a difference. Just like I could have shaded this side instead of this side. It don't make a difference. But look what I'm doing, right? So we're saying that GLI, which is this whole thing, is equal to this plus this. That don't even make sense. Because how is this whole thing this whole angle, GLI, this whole angle from here to here, going to be equal to just this piece, these two pieces put together. That don't make sense. You know? That's almost like saying, all right, we're going to take $40, right? We're going to take $40, right? And $40 is equal to, and $40 is split 20 and 20, right? $20 and $20, right? And then you take half of $20, half of one of the $20 or one $20 bill, and half of the other $20 bill, and put them together, put those two halves together, which is 10 and 10 for real. And then you try to tell me that that's equal to $40? No, 20 ain't no way $20 is equal to $40. They not the same thing. They're not the same thing. So that's what this will be saying. So this is no good too. This is no good too. But you see, I hope like I've driven home the larger point, which is that geometry is important because it teaches you how to think critically. So it teaches you how to prevent people from finessing you, right? Because somebody will finesse you and smile in your face and act like they cool, right? Act like they're your man, act like they're on your side, right? Because they know how to finesse you. And if you don't understand what's going on in front of you, you will go for it. You will go for the okie doke every time. So what I'm telling you is focus in geometry, because what geometry can do and what it's supposed to do is teach us how to think. Not what to think, but how to think, right? So we don't get taken advantage of by corporations, by politicians, by, government entities, by anybody, by, your significant other, anybody that, somebody at your job, somebody that don't have your best interest in mind. See? And so when people ask that question, like, what I got to learn this for, what I'm going to use geometry for, do you think it's a valuable skill to know how to not get finessed in life? Like, I think that's real valuable. So, but a lot of times, but see, the thing is, when a lot of people say that they thought geometry was irrelevant, it's not really their fault, because nobody put it to them like that. Nobody said like, well, listen, if you can learn geometry and the geometric rules and the principles and the proofs and the postulates and the theories and the corollaries and everything, and you can learn how to think for real, and you can learn how to think through that, that's a skill that's what we call transferable. You take that out the classroom with you. It's not like you're going to leave it in the classroom. Nah, if you train your mind to think that way, once you go out into the street, you're going to be able to do the same thing. Once you go to your workplace, you're going to be able to do the same thing. Once you go into any arena, you'll be able to do the same thing. So I'm telling you, geometry is one of the most important subjects out there, right? Because it teaches you how to think, and it teaches you how to defend yourself from being taken advantage of. All right. So that's that. I showed you how to do this, but the way you really learn is by practice. So hopefully you got more practice problems out there, more practice problems that you could work on and work the way you get to practice using these definitions, using these terms and understanding and applying their definitions. Also looking at relationships between angles. Hopefully you can go do that, but you got to practice though. Like for real, you got to practice. All right. Because practice is the key. All right. If you don't practice, like it don't matter. You can watch this video like all day long, but if you don't actually, get down and dirty and practice problems like this on your own, then you'll never really learn it. All right. So go get some practice, and I'll catch up with y'all on the next video. Peace.